Okay, let's go with this. Trigonometry. It says if A lies in the second quadrant and 3 tan A plus 4 equals 0, then the value of 2 cot A minus 5 cos A plus sin A is equal to what? We are asked to find the whole of this. You should know that cot A is equal to 1 over tan A. You should note that. So this is a kind of a very practical question. We are to solve illustratively. We are to use diagrams for this question. What does it mean when they said when it is stated that A lies in the second quadrant? You should know that in trig there is what we normally do. We do call this ASTC. It means that this is the first quadrant. You should know that this is the second quadrant, and this is the third, and this is the fourth quadrant. It goes anti-clockwise. So at this first quadrant, A here stands for all, and it means that the sine, the cosine, and the tangent are all positive at the first quadrant. And in the second quadrant, it means that this is for sine, S is for sine, T is for tan, and C is for cosine. It means that sine is the only positive thing at the second quadrant. And for the third quadrant, tangent is the only positive stuff. And at the fourth quadrant, cosine is the only positive one at the fourth quadrant. So now we use that to solve this question. It says 3 tan A plus 4 equals to 0. So from here we can say tan A is equals to negative 4 over 3. I took this here and divide both sides by 3. So now I got my tan A already. So if A lies in the second quadrant, it means that this is very true, because my answer for tan A must be in negative. Note that it must be negative. And another example, I want to draw the the right angle triangle to illustrate the SOH-CAH-TOA. We already know that tan is opposite over adjacent. Let's call this the A. This is the angle A, and this is the opposite. What is our opposite here? This is 4. We are not going to use the minus sign because this is a triangle, and our adjacent is 3. So finding this, we use Pythagoras theorem that says this is equal to the square root of 4 square plus 3 square, and that is square root of 16 plus 9, that is square root of 25, and that is 5. So the hypotenuse is 5. From this diagram we can actually find any of the trig we want to find. We can find the cosine, we can find the sine. So from this diagram, what is cos A? We already know from the question we are to find cot A minus 2 cot A minus 5 cos A plus sine A. So I want to find each of them. So from this diagram, cos A would be equals to cos A, we all know from SOH-CAH-TOA, we all know that cos A is adjacent over hypotenuse. What is our adjacent here? Our adjacent is 3 and our hypotenuse is 5. Still keep in mind that A lies in the second quadrant. What that tells us is that only sine must be positive, meaning that cosine should be negative. So we have to put our negative sign here. And for our sine A should be opposite over hypotenuse. What is our opposite? 4. Hypotenuse here is 5. So our sine A would be 4/5 because A lies in the second quadrant, and the second quadrant sign must be positive. So you get that. So our cot A, I stated earlier that cot A is 1/tan A, and now we got our tan A as minus 4/3. So our cot A would be equals to 1 over minus 4/3 is the reciprocal. So I can write that as -3/4. You get? So now, bringing in all our values, I can evaluate this 2 cot A. Instead of cot A, I write -3/4 minus 5 cos A, which is -3/5, plus sine A, which is 4/5. Now from here you get 1, 2, that is equals to -3/2 plus 3 plus 4/5. The LCM gives us 10, and 10 into 2, that is 5, times -3, that is 15, -15, and this is plus 30, and this is plus 8. And now -15, this is the LCM, 10, -15 plus 30, that is 15. 15 plus 8, that is 23. So our final answer to the question is actually 23/10. So simplifying, evaluating 2 cot A minus 5 cos A plus sine A, when 3 tan A plus 4 equals 0, we have 23/10. And don't forget, A lies in the second quadrant. Now you understand what it means by lying in the second quadrant, third quadrant, first quadrant, and fourth quadrant.